Okay. I'm gonna sort this chair out. Keep sinking. All right. It's a little bit of a. It's funny. I mean, a little bit of a rewrite happen. Cause, well, X11 does not work. Not because of X11, but I updated the OS, upgraded it to the latest version, and they rewrote it to work with Wayland. So I'm gonna do the same. I mean, there's no point justifying it because it's happened. Okay, let's have a look. Start from the beginning. I think I'm gonna take it slow. And also another thing that I realized is one of the reasons I get stuck is I don't have a very good mechanism for feedback. It's something I want to like focus on to get better feedback or any feedback within the context of what I'm building. Okay, so I'll put that to the side. I'll revisit it. And for now, let's look into Wayland. This is my mic. Wayland is a replacement for X11 Windows System protocol and architecture with the aim to be easier to develop, extend, and maintain. Right. Wayland is the language that applications can use to talk to a display server in order to make themselves visible and get input from the user. Okay. Wayland server is called a compositor. Gotta unlearn some of these words because I think well, I mean, it could mean the same thing. No, it doesn't. Compositor in Xrender allows you to blend two layers or more layers. Applications are Wayland clients. Okay, so it's compositor and client. Wayland also refers to a system. Not Discord. Wayland also refers to a system architecture. It's not just a server-client relationship between. Okay, refers to a system architecture. It's not just a server client. Actually, the mic sounds really good. Quite happy with how I set it up. Quite clean. It's not just a relationship between a compositor and applications. Oh, right, okay. Applications are Wayland clients. There is no single common Wayland server like Xorg is for X11, but every graphical environment brings with it one of many compositor implementations. Okay. I didn't know there was only a single server when using X11. Kind of makes sense because you. No, it doesn't make. I mean, I didn't know. One of many compositor implementations. Window management and the end user experience are often tied to the compositor rather than swappable components. Okay. I'm not really a big fan of this, because I think at least when you're developing it, it's better to let it be like a standalone window, not tied to the window manager. Well, we'll see. Tied to the compositor rather than swappable components. Okay. A core part of Wayland architecture is libWayland, an inter-process communication library that translates a protocol definition in XML to C language API. I don't like this either. But I read somewhere you can just use a buffer. Which is what I will be using. This library does not implement Wayland. It merely encodes and decodes Wayland messages. The actual... Okay, hang on. Translates protocol definition in XML to a C language API. Okay, that's what we need. The library does not implement Wayland. It merely encodes and decodes Wayland messages. Okay. The actual implementations are in the various compositor and application toolkit projects. All right, let's take some notes. But you know, the X11 thing that I've done is like, it's not total waste. Because I can later on, what I can do is I can check if the system supports X11 or Wayland, and then based on that, dynamically load X11 or Wayland, and then run that instead. Only to know how to do that. Yeah, I can reuse it later. Wayland XML Wayland to C. Wayland does not restrict where and how it is used. A Wayland compositor could be a standalone display server running on Linux kernel, mode setting, and evdev input devices. What is an evdev? Or any other operating systems, or a nested compositor that itself is an X11 or Wayland application. Interesting. So you can run it within an X11 application. That's cool. Interesting. Wayland can even be used in application internal communication, as is done in some web browsers. Okay. Application internal communication. Okay, all very exciting stuff. Well, interesting. Where do we start? I think we'll look at the architecture, FAQ, document. We'll look at all of it. In the midnight hour. Okay, Wayland. I think it seems good enough place to start. Good way to understand the Wayland architecture and how it is different from X is to follow an event from the input device to the point where the change it affects appears on screen. Right, this is where we are now with X. Multiple X clients, there's an X server, compositor. Yeah, the compositor is separate. But it also means something different in X11. Where is one here? What is evdev? Evdev. Event device, okay. Linux kernel standard generating interface for handling input events from, okay. Glad I looked that up. What is a KMS? Never mind. Oh, hang on. I don't know. Okay. Can be event device or a kernel. Then where's, can't really see anything. Too bright. Okay, that's two. X server passes this on to the X client. X client sends something back. Sends it to the compositor. Compositor does something, sends it back and sends it back. The X server then sends it back to the kernel or event device. The kernel gets an event from an input device. Okay. And sends it to X through the evdev input driver. What was evdev again? Event device. Device event. Event device. The kernel does all the hard work here by driving the device and translating the different device-specific event protocols to the Linux evdev input event standard. The X server determines which window the event affects and sends it to the clients that have selected for the event in question on that window, right? Like the X server. Oh, maybe not the X server. The X server doesn't actually know how to do this right, since the window location on screen is controlled by the compositor. And maybe transformed in a number of ways that X server doesn't understand. The client looks at the event and decides what to do. Oh no, I think I missed something. Oh, I read it at once. They were two different. I'm gonna start again. Kernel gets an event from an input device and sends it to X through the evdev event device input driver. The kernel does all the hard work here by driving the device and translating different device-specific event protocols to the Linux evdev input standard event. Right, okay. Translates the events from the device. Okay. And then changes it to the EV event device type or something. And then sends it to X server. The X server determines which window the event affects and sends it to the clients that have selected for the event in question on that window. Okay, yeah. The server doesn't actually know how to do this right. Does that mean the X server receives all the events, but you only see or access the ones that pertain to your client? Right, okay. The X server doesn't actually know how to do this right, since the window... Okay, this part I got, because the client looks at the event and decides what to do. Often the UI will have to change in response to the event. Perhaps a checkbox was clicked and the pointer entered a button that must be highlighted. Thus, the client sends a rendering request back to the X server. The X server receives the rendering request. It sends it to the driver to let it program the hardware to do the rendering. The X server sends it to the driver. Okay. The X server also calculates the bounding region of the rendering and sends that to the compositor as a damage event. The damage event tells the compositor that something changed in the window and that it has to recomposite the part of the screen where the window is visible. Interesting. So if the window is not visible, well, then it won't get the event in the first place. Maybe. Compositor is responsible for rendering the entire screen contents based on its scene graph and the contents of the X windows. Yet it has to go through the X server to render this. Right, okay. The compositor does the rendering, but to finish the rendering, X server has to do it. I'm not really sure I fully understand that. Contents based on a scene graph and the contents of the X windows. Yet it has to go through the X server to render this. Okay. The server receives the rendering requests from the compositor and either copies the compositor back buffer to the front buffer or does a page flip. I don't know what I think I know what a back buffer is, but I don't know what a front buffer is. Ah, it's like maybe the next frame. Kinda. I'm guessing this is... Oh yeah, I think the back buffer is the buffer that we use. I remember I called it back buffer for a while. And the front buffer, I think, is what you see on the screen. Or does the page flip? I don't know what that is. In the several case, the X server has to do the step so it can account for overlapping windows. Which may require clipping and determine whether or not it can page flip. However, I also just realized why it was called the back buffer. Because when I think the first few episodes of Handmade Hero, Casey calls it a back buffer. But I never understood, I never questioned why. Now it makes sense. However, for a compositor which is always full screen, this is another unnecessary context switch. Okay, I kind of get it. Right, so the X server updates the buffer, but then the compositor has to decide how much of the buffer to show, because part of the window could be behind another window. As suggested above, there are a few problems with this approach, but it has been working for like 40 years. But no reason it couldn't be better. The X server doesn't have the information to decide which window should receive the event. So it sends it to all, nor can it transform the screen coordinates to window local coordinates. And even though X has handed responsibility for the final painting of the screen to the compositing manager, X still controls the front buffer and the mode setting. Most of the complexity that the X server used to handle is now available in the kernel or self-contained libraries. KMS, ebdev, Mesa, font config, freetype, Cairo, Qt, etc. Set the window manager. I know this is an event device. The rest, I know free type. But the rest of it, no. In general, the X server is now just a middleman that introduces an extra step between applications and the compositor, and an extra step between the compositor and the hardware. Okay, so I kind of understand the X architecture. Now let's look at the Wayland architecture. In Wayland, the compositor is the display server. We transfer the control of KMS and event device to the compositor. So you send a Pietra the detective. Hey, did I just call it detective? I don't know, you tell me. Does it sound okay? Yeah. I don't know if something failed. It's because I had to like reinstall my OS a few days ago. And yeah, I had to reset OBS. Maybe you can tell me, like, does it sound okay? And well, yeah, maybe it's mostly the sound, really. The video. Okay, thank you. Well, and thanks to the OS upgrade, I've also got to change my window system. Okay, in in Wayland, the compositor is the display server. We transfer the control of KMS and event device to the compositor. The Wayland protocol lets the compositor send the input events directly to the clients, and lets the client send the damage event directly to the compositor. What was the damage event again? Oh yeah, here. The Xserve also calculates the bounding region of the rendering and sends that to the compositor. Okay, so it's the area affected on the screen. I forgot where I was. In Wayland, the compositor is the display server. We transfer the control of KMS and event device to the compositor. Well, the compositor is the display server. Okay. The Wayland protocol lets the compositor send the input events directly to the clients and lets the client send damage event directly to the compositor. Okay. Kernel gets an event and sends it to the compositor. Similar to Xcase, which is great since we get to use all the input drivers in the kernel. Hang on, BRB. had an emergency. All right, okay. Where was I? Okay, so the compositor. What's wrong with my chair? The compositor is the display server. Okay, so there's no separation between the server and the compositor. So you get an event directly in the compositor, it sends it to the client. Client updates the back buffer, sends it to the compositor. The compositor looks through its scene graph to determine which window should receive the event. If the scene graph corresponds to what's on the screen, excuse me, and the compositor understands the transformations that it may have applied to the elements in the scene graph. Thus, the compositor can pick the right window and transform the screen coordinates to window local coordinates. Okay, by applying the inverse transformations. The types of transformation that can be applied to window is only restricted to what the compositor can do, as long as it can compute the inverse transformation for the input events. I'm not sure what this means. Types of transformation is only restricted to what the compositor can do. We'll just put that on a shelf for now. You'll come back to it later. As in the X case, when the client receives the event, it updates the UI in response. But in the Wayland case, the rendering happens in the client. Oh, interesting. That is actually much simpler. So I don't need to like create an image or a pix map. I like that. And the client just sends a request to the compositor to indicate the region was updated. Perfect. Compositor collects damage requests from its clients and then recomposites the screen. The compositor, don't know, can then directly issue an IOCTL. What is an IOCTL? CTL. Input output control. But there's a different one here. System call manipulates the underlying device parameters of special files. Terminals will be controlled with IOCTL operations. Okay. I mean, I don't get it. I don't know what it does exactly, but I don't know what a page flip is either. Process where the graphics compositor. Ah, okay. What is KMS? Kernel Management System. I mean, that's just a guess. Okay. But in the X server, you do send it the back buffer. Here you update the window. Yeah, I'm not sure how the buffer is updated. Hey Tharas, how you doing? Wayland rendering. Okay. Yeah, that was my question too. One of the details I left out in the above overview. Working on my AI tool. What tool are you working on? It creates and evaluates lists. Excuse me. Okay. I mean, I mean, from that description, doesn't sound like a very useful tool. But I mean, I'm sure there's more to it. One of the details of overview is outline. Okay. Let's say Wayland. You can, like, yeah. Let's say Wayland rendering. I mean, I don't know. I don't want a list, but you want to give me a list, so oh, okay. But I don't want to know. Oh, okay, you mean a list of well, you could say Linux distributions. Right, okay, so by removing the X server from the picture, we also removed the mechanism by which X clients typically render. Yep. But there's another mechanism we're already using with DR12. Is it DR12 or DRI? Looks like an I. What is that? Direct rendering infrastructure. User space applications talk directly to graphics of hardware. Okay. Okay, so it's like a rendering library. The mechanism we're already using with dir2 under X, direct rendering. With direct rendering, the client and the server share a video memory buffer. The client links to a rendering library such as OpenGL that knows how to program the hardware renders directly into the buffer. The compositor in turn can take the buffer and use it as a texture when it composites the desktop. After the initial setup, the client only needs to tell the compositor which buffer to use and when and where it has rendered new content into it. So this leaves the application, this is the interesting bit, with two ways to update its window contents. Render the new content into a new buffer and tell the compositor to use that instead of the old buffer. Oh, I don't like this already. First one. The application can allocate a new buffer every time it needs to update the window contents, or it can keep two buffers around and cycle between them. The buffer management is entirely under application control. Okay. What is the other option? I mean, this is actually not bad. You could have two buffers. Render the content in new content into a buffer that it previously told the compositor to use. While it's possible to just render directly into the buffer shared with the compositor, this might race with the compositor. Okay. NixOS. Okay, so that's the list. Okay. Oh, I mean, it's a strange tool, I have to say. Don't know what you do with this. Would you use this tool? Okay, personal use. Alright, that's fine. I love this. Okay. That makes sense. I mean, that was my guess. That you probably needed it for something. Caught myself doing this list manually. I guess. I mean, yeah. I guess you could have just asked you could ask ChatGPT to give you a list. I'm guessing that's what you're doing. Okay. Where was it? What happens is that repainting the window contents could be interrupted by the compositor repainting the desktop. The application gets interrupted just after clearing the window. Before rendering the contents, the compositor will texture from a blank buffer. Right. The result is that the application window will flicker between a blank window or half-rendered content. Yes. For example, when I was using X11 and when I made the resize the window, the buffer would change and then it would flicker. I did that before and I needed like 20 different prompts and spreadsheets. So I was like, it can be automated. Yeah, can be. I mean, I don't I'd never like don't care about this, and yeah, I mean it's kind of funny that you build a tool for it. The traditional way to avoid this is to render the new content into a back buffer. Yeah, and then copy from there into the compositor surface. The back buffer can be allocated on the fly and just big enough to hold the new content. Or the application can keep a buffer around. Again, this is under application control. Okay, so just have a single back buffer. I do like this approach. It's quite simple. And just copy it onto the compositor. Option 2 so far. I mean, option 1 is not bad either. I'm learning that owning a tool is important in the long term. You can add features and you would not rely on other people a lot. Yeah, I mean, and it's kind of fun to build your own tools. Or like it's fun to build tools for yourself. In either case, the application must tell the compositor which area of the surface holds new How will the application holds new won't it be the entire screen or like entire window? When the application renders directly to the shared buffer, compositor needs to be noticed that there is new content, but also when exchanging buffers, the compositor doesn't assume anything and needs a request from the applications before it will repaint the desktop. The idea that even if an application passes a new buffer to the compositor, only a small part of the buffer may be different, like a blinking cursor. Ah, interesting. So it will just repaint the section that is different. I was thinking about this when using X11. Hardware enabling for Wayland. Share buffers efficiently between processes. There are two sides to that. On the client side, we've defined Wayland ETL platform. I think I can just skip that for now. What's next? Oh, it's a fork of the X server. Oh, okay. I mean, okay. Somebody assumed. Imagine if you just read the question. Oh, it's like, and you never read the answer. That'd be funny. It's a protocol between, what's the license? MIT expat. Why duplicate all this work? Oh, okay, now I understand. These are like questions people just assume. I wonder if it's meant to be like ironic or like it's like a backhanded insult. What is the drawing API? I like this FAQ, it's quite cool. Whatever you want it to be, honey. Shadow buffer. Okay. Is Wayland replacing the X server? Mostly yes. Why not extend the X server? What is wrong with X? I mean, just read the architecture. What about the overhead of running X on Wayland? I love Linux's decade-long migrations. Yeah, I mean, you kind of have to, right? Can't just migrate it on the fly. Yeah, you did say love. Oh, okay, in quotes. Have you looked at River Window Manager? No, I haven't. Well, I mean, since I use Pop OS, comes with a window manager. Just use that. Like, I don't like the animation. They haven't. I mean, it's still under construction. Yeah, they rewrote the thing in Zig. Sorry, not Zig. Rust. And they haven't added the animation config yet. But that's the only complaint. Anything that is desktop Linux related makes me a bit sick. You mean the migration? Okay, we can just skip the FAQ. Intel Corporation. Interesting. Wayland. Written by Intel. Is it? Oh, right, okay. Created Wayland in 2008 while working at Red Hat. Oh, okay, he was working at Intel. That makes sense. Documentation, deals with restriction. Oh my god. Oh, it's not too bad. Still don't know what the library is called though. Preface. Oh, model operation. It's library API. Perfect. Christian has to fill this up. I guess you never got around to it. It's a 2-decade-long to-do list. I did read this. Compositing manager. Yep. System session embedding compositor. So I guess as long as it supports Wayland, I can use the same pixmap. Oops. Interesting. So I could support. Where's my render? So I would have to just change this method technically, and I could use the same bit. I mean, it's worth a shot. X11 lets clients embed windows from other clients, lets clients copy pixmap contents rendered by another client into their window. X was Wayland architecture. Already read this. Basic principles. What is the library called? Oh my god, I don't like the first sentence. The Wayland protocol is an asynchronous object-oriented protocol. Because one of the challenges is when using Zig with a C library is if the library, oh no, but I did actually read it in the architecture. The memory is handled by the application. So I guess no need to worry about that. Okay, basic principles. It's a bit tiny. The Wayland protocol is an asynchronous object-oriented protocol. All requests are method invocations. All requests are method invocations on some object. The requests include object ID that uniquely identifies an object on the server. Each object implements an interface, and the requests include an opcode that identifies which method the interface to invoke. Okay. The protocol is message-based. A message sent by a client to the server is called a request. Client to the server. Yeah. A message from the server to a client is called an event. A message has a number of arguments, each of which has a certain type. See the section, it's I think down below. Additionally, the protocol can specify enums which associate names to specific numeric enumeration values. These are primarily just descriptive in nature. At the wire format level, enums are just integers. But they also have a secondary purpose to enhance type safety or otherwise add context for use in language bindings or other such code. This latter usage is only supported so long as the code written before these attributes were introduced still works after. Add context for use in language binding. In other words, adding an enum should not break API. Okay. Enums can be defined just as set of integers or bit fields, specified via bit field, boolean attribute in the enum definition. Enum definition. Enum. If this attribute is true, the enum is intended to be accessed primarily using bitwise operations. For example, when arbitrarily many choices of the enum can be ORed together, if it's false, okay, once you OR them together, if it's false or the attribute is omitted, then the enum arguments are just a sequence of numerical values. Okay. The enum attribute can be used on either uint or int arguments. However, if the enum is defined as a bit field, it can only be used on uint args. The server sends back events to the client. Each event is emitted from an object. Events can be error conditions. The event includes the object ID and the event opcode. Okay. From which the client can determine the type of event. Events are generated both in response to requests, or spontaneously when the server state changes. Okay. Do you have to sort of subscribe to an event? Because I think it's sync notify. What is it called? Oh, event notify. Oh yeah, select input. Excuse me. State is broadcast on connect. Okay. Events are sent out when state changes. Clients must listen to these changes and cache the state. There is no need to query server state. And you can't either. Okay. The server will broadcast the presence of a number of global objects, which in turn will broadcast their current state. The interface's requests and events are defined in protocol/Wayland. This XML is used to generate the function prototypes that can be used by clients and compositors. The protocol entry points are generated as inline functions, which just wrap the WL proxy functions. The inline functions aren't part of the library ABI, and language binding should generate their own stubs for the protocol entry points from the XML. So, excuse me. We got to use this protocol thing. No, what was it called? There was another library. libwayland. You can use that to translate the XML coming from the server to C. The protocol is sent over a Unix domain stream socket, where the endpoint is usually named Wayland 0, although it can be changed via Wayland display in the environment, beginning in Wayland 1.15. Implementations can optionally support server socket endpoints located at arbitrary locations in the file system by setting Wayland display to the absolute path of a server endpoint. Sorry. Points listen. Every message structured as 32-bit words. Values are represented in the host's byte order. The message has 2 words in it. The first word, sender's object ID. The second has 2 parts of 16-bit. The upper 16 bits are the message size, starting at the header. The lower is the request/event opcode. Okay. I'm pretty sure I'll forget this. 32-bit words. So there's 2 words. Get the object ID and the opcode. Okay. Message size. Starting at the header. What does this mean? I guess I think you can use the lib Wayland to translate this. We'll figure this out later. Payload describes the request/event arguments. Every argument is always aligned to 32 bits. Where padding is required, the value of padding bytes is undefined. There is no prefix that describes the type, but is inferred implicitly from the XML specification. It's a bit cold. The representation of argument types are as follows. Int uint. Fixed. Signed 24.8 decimal numbers, which offers a sign bit, 23 bits of integer precision and 8 bit. Oh, okay, 23. Not okay. 8 bits for decimal precision. This is exposed as an opaque struct with conversion helpers to and from double and int on the C API side. String followed by UTF encode string contents, terminated null byte. Okay. Then padding to a 32-bit boundary. Unsigned 32-bit length. (32-bit boundary). So the entire string is 32 bits. So about maximum of 4 words. 4 letters, sorry. Object, new ID, array, or is it 32-bit? No, not sure. We'll look at that later. It's not stored. What about the array? I think it's just a pointer. And the length. Not sure. But even for the array. The file descriptor is not stored in the message buffer, but in the ancillary data of the Unix domain socket message control. The protocol does not specify the exact position of the ancillary data in the system. Except that the order of the file descriptor is the same as the order of messages and FT arguments within messages on the wire. I'm not fully sure I understand that. In particular, it means that any byte of the stream, even the message header, may carry the ancillary data with file descriptors. Okay. Clients and compositors should queue incoming data until they have whole messages to process. As file descriptors may arrive earlier or later than the corresponding data types. Interfaces. Display registry, callback, compositor, some buffer. What does the buffer look like? It's versioned, and every protocol object implements a particular version of its interface. I guess that can be checked by the definition. Creating objects. Each object has a unique ID. IDs allocated by the client are in the range 1 to that's to the it looks like 32-bit. Okay, so it's not really 0. 0 is reserved for null or non-existent object. For efficiency purposes, the IDs are densely packed in the sense that the ID n will not be used until n-1. Okay. This ordering is not merely a guideline, but a strict requirement. And these are implementations of the protocol that rigorously enforce this rule. And there are implementations, including ubiquitous libwayland. Okay. The compositor is a global object advertised at connect time. Call W compositor singleton. A surface manages a rectangular grid of pixels that clients create for displaying their content on the screen. Clients don't know the global position of their services and cannot access other client services. That's a good idea. Once the client has finished writing pixels, it commits the buffer. This permits the compositor to access the buffer and read the pixels. When the compositor is finished, it releases the buffer back to the client. Okay. Because I did read somewhere, you need to let the compositor know when to update the buffer. Sorry, update the screen from the buffer. Input. Seat represents a group of input devices including mice, keyboards, touchscreens. A seat represents I mean, I think we can look at this later. WL seat. XKB on Wayland. Output. An output is a global object advertised at connect time or as it comes and goes. Basically, xrender over Wayland. Can you still use xrender? So, hang on. Does that mean I can keep this? Oh, but it's an X11 extension. But maybe there's a Wayland extension. Because all I really need is the refresh rate from xrender. Data devices, drag and drop. Okay, I want to see the library. The identification, protocol specification. Wayland lib. Is that an example? Wayland cursor. Wayland client. Undo that. No manual and what about lib Wayland? Let me ask Cloud. What is the lib Wayland? No. What do I need to know? What is the Wayland? How can I Wayland libs check it? So it is Wayland client. What about lib Wayland? Okay, lib Wayland is the same thing. How can I check if Wayland client lib present? What is package config? A system for configuring build dependency information. Okay. So you do package config and the dependency. This Wayland client. Okay. Check the version. Version Wayland client. About the server. Okay. That's a good start. I can just go here. Can I check? Oh, I think it might be might be the version of package config. Okay, that was stupid. Find prefix. Exist. X version, exact version. At least version. Yeah, let's try that. Oh, sorry. Package. I don't get it. Is there something there? No, there isn't. Okay, so but at least it exists. Hang on. Found, yeah. Okay. But that's not what. Does it always return blah? Okay. I just had to check. Module name options. Okay, so let me do Wayland client. Get rid of that. Let's keep X render. Get rid of these. Get rid of that. Let's see. Include Wayland client. See, import failed. Two compilation errors. I do think this might not be right. How can I get the name of a system library? Wayland. I want it to link system library in build Zig. Yep, it says Wayland lib. Sorry, client. Is that a typo? No, that isn't. Yes, it does exist. Can you use package config to find a library? Oh, it returns nothing. General options, module specific. Config, I've used that before. Maybe that's why it can't be found. Is it lib? x86 oh, okay. Oh no, it does look there. Oh, okay. Lib Wayland. Build. Okay, so it's able to find the library, but what's the error? Lib Wayland client, no found. You can find xrender. User include x11 extensions xrender. Maybe somebody else done it before. Wayland from the wire. I did read somewhere this was kind of scammy. Zig.news. It was on the Zig website. Or was it this one? No, I don't know. Wayland Zig. exe root module add import Wayland. So I need to wait to find out how to install the version of Wayland. Scanner.add system protocol. Because you do need to generate XML. I did see that somewhere. Generate XML. Not sure how. And then does he have read only? I think a Wayland compositor in Zig. Alright, I've got some things to find out for tomorrow. Where is it? 6:30? Okay, I think I'm gonna call it today there. I'm gonna save this. Yeah, don't know this. That up there. I don't know how to do that either. So I need to find out the library. I need to generate the XML, the C code from the XML, and then I'll be able to use it. Okay, there's a few things to do, but I think that's a problem for tomorrow. All right, I'm gonna call it a day there. Hope you have a good one. I shall see you back here tomorrow. What's tomorrow? Saturday. Yeah, I think it should be good for tomorrow.